This problem right here. This question is asking a 120 voltage series DC motor has an armature resistance of 0.2 ohm and a series field resistance of 0.16 ohm. The speed of the motor are 1326 revolutions per minute. If it's operating at an armature current of 35 ampere, the ratio of the field fluxes at 35 ampere and full load current is 1.2 for a speed of 1200 revolutions per minute. The core losses are 200 watts and the mechanical losses are 240 watts at full load. Assume that the mechanical losses vary as the square of the speed of the motor and that the core losses are constant. First question is asking the rated speed is 1050 revolutions per minute. Calculate the current input at full load. Second part is asking what is the efficiency of the motor at full load. Okay, now before we go and do that, let's go ahead and calculate EB1. Let's note down the given informations. We have V that's provided to be 120 voltage and RA provided to be 0.2 ohm, RSC provided to be 0.16 and the speed provided to be 1326 and IA is provided to be 35 ampere. Okay, here we are trying to find out EB1. To find out EB1, this is the formula. EB1 is equal to V minus I times RA plus RSC. Here V is 120 volt. The current given is here IA is, we have IA, but we had to find out I. To find out I, we had to use the fluxes. The given fluxes, flux at 35 ampere divided by flux at full load. Okay, here we have, and here they have mentioned the ratio of the fluxes at 35 ampere and full load current is 1.2 for a speed of 1200 revolutions per minute. So the flux for 35 ampere divided by flux for full load is equal to 1.2. Okay, so 35 divided by I, here we need for full load, I is equal to 1.2. So I is equal to 35 divided by 1.2, and if you calculate, that's going to give you 29.16 ampere, and that's the current we had used right here. This is 29.16 ampere multiplied by armature resistance, that is 0.2, and the series resistance, that is 0.16, and if you calculate, you're going to get 109.5024 volts. This is EB1. Okay, now here our purpose is to find out the current, I2 current. To find out the I2 current, we had to use this ratio. N is directly proportional to EB. Okay, speed is directly proportional to the voltage. So we can create an equation that is N1 over N2 is equal to EB1 over EB2. Now N1 is what? Here we have this 1200, that is our N1. Okay, and N2 is given in the question because this is the condition we are required to find. This is our N2. Let's go ahead and plug it in this equation. Here we want to find out EB2 because EB1 is already found. Let's plug all the values. N1 is equal to 1200, N2 is equal to 1050, and EB1 is equal to 109.50, and EB2 is what we are trying to find. And if we rearrange this one, that will give us EB2 that's equal to 95.816 voltage. Okay, now let's go ahead and plug it in the equation. EB2 is equal to V minus I times 0.2 plus 0.16 EB2 we found out that is 95. Let's plug it right here. 95.816. That's equivalent to 120 minus I. Let's put I2. I2 times 0.2 plus 0.16. And from this one we can calculate I2. That gives us 67.18 ampere. This is our I2 value. And the second part is asking what is the efficiency of the motor. To find out the efficiency, let's use a different color. Let's continue this one right here. P input is equal to V times I2. V is 120 and I2 is 67.18. 7.18, and that gives us 8061.8 watts. And P ohmic is equal to I2 square times armature resistance plus series resistance. And I2 is what? I2 we calculated, that is 67.18 square plus times 0.2 plus 0.16, and that gives us 1624.73 watts. This is our P ohmic. Let's get rid of these things. And continue right here. Okay, we calculated P ohmic. Now P out is equal to P input minus P ohmic plus P core plus P mechanical. Now here we have all the information except P mechanical. Let's go and find out P mechanical right here. To find out P mechanical, this is the ratio. P mechanical is directly proportional to the speed square. So P mechanical 1 over P mechanical 2 is equal to N1 square over N2 square. P mechanical 1 is provided. Mechanical losses 240 watts. 240 divided by P mechanical 2, that's what we are trying to find. P mechanical 2, that's equal to 1200. N1 is 1200 divided by N2 is 1050 square. And from this one we can solve for P mechanical, and that is equivalent to 183.75 watts. Now let's bring this equation right here. P out is equal to P input. P input we calculated, that is 8061.8 minus P ohmic. P ohmic is 1624.73, 1624.73 plus P core. Here we have the core loss, that is 200 plus P mechanical. P mechanical is 183.75, and from this one we calculate P out. That gives us 6053.32 watts. And from this one we can calculate the efficiency, because to calculate the efficiency all we need is P output and P input. That's why we calculate all these things. We calculate P output, P input we calculated initially. To find out the efficiency, this is the formula: P out over P in multiplied by 100. Now P out is 6053.32 and P input we calculated, that is 8061.8 multiplied by 100. That gives us 75.086%, and that is our efficiency. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electromechanical system, There are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.